right? So yes, client administration we discussed. This is the what we discussed, client administration and work process administration we discussed. So before we go for the one of the large topic, transport administration, we have small topics are there. So theoretical topics, some other transactional code based topics are there. So those are the some topics are like in that one of the topics is called the one of the topic is called the RFC types. So it's not the connection types. So RFC connection types. How many RFC connection types we have? Connection types in SM59. RFC connection types,
Fine.
HTTP,
right? So
Four.
in that, can you name it some of the connection types?
ABAP to ABAP.
TCP IP connection,
TCP
Okay.
IP. HTTP.
Okay. So these are the
internal connection.
types here. But they are the RFC types are there. Except connection types, there are the some RFC types. These are the some theoretical topics actually. This is the so in that what is RFC first of all? What is RFC?
Remote function call.
Okay. So that is the abbreviation. But what is the RFC? RFC is a mechanism that allows business applications to communicate or exchange the data or information with the other system. The RFC stands for remote function call, but that remote function call, why it is used means to allow business applications to communicate each other. Also, the exchange the information between so we both of us. So why we use the Bluetooth from your mobile, my mobile? So to connecting to the connecting to the your mobile or connecting to my mobile, exchanging the data, movies, songs, whatever it may be. So that normally exchanging the information, we will use the Bluetooth connectivity. Then we will exchange the information, right? So same as like here also, RFC is the SAP naming. It will use to exchange the communication or information. So they are the we can contact from one system to ABAP system to non-SAP and SAP to SAP, SAP to non-SAP. So multiple ways we can establish the connection. Multiple ways we can establish the connection here. That is called the RFC functions. So why we have to use the RFC connection means here to exchange the information. Suppose you have the SAP ECC system is there. You want to send the data to the BW system, or you want to send the data to the CRM system, you want to send the data to the SCM system. So here you have the multiple systems here. So you want to exchange the information, you want to send the data to the one system. So then you need the RFC destination. Via RFC destination, the data flow will happen. The data flow will happen from one to another. The data flow will happen here, right? So like this, the data will transfer will happen to the here, right? From here to here, again from here to here, again from inflow to outflow. There are the communication between the servers, systems, technologies, right? Communication between the servers, one flow or two-way communication or one-way communications. So we can use it. We can use it here, this communication. So RFC is a SAP protocol to handle the communication between the systems. To simplify the to simply exchanging the data from one system to other system with different formats, different way it will convert it, it will send the data to here, right? So one is the protocol, SAP protocol here, SAP protocol here. So here SAP use the CPIC communication actually.
10,500.
SAP will use the SAP will use the CPIC communication. So SAP will use the CPIC communication. This is the one of the protocol here. Just remember CPIC. CPIC is the it will use the this protocol will be used to transfer the data between the systems. CPIC. So common programming interface for communication. So that is the protocol it will use to transfer the data between the systems here, right? So in that RFC communications interface based upon the CPIC communications, right? It will use the This RFC library will use the C programming language in the Windows systems, and it will use the protocol for calling the target systems and everything. It will use the systems here. So the main advantage of RFC is to reduce the efforts of programming. So like it will convert the data into understandable format by the remote systems here. Understandable format by the remote systems here, right? Understandable format. And also there the RFC, there are the types of four types of RFCs are there in SAP here. There are the four types of RFCs are there here. One is the synchronous communication. One is the synchronous communication here. Synchronous communication here. The second one is the asynchronous communication. The third one is the transactional RFC. Transactional RFC here. Transactional RFC. The fourth one is called the queued RFC. Queued RFC. So there are the four types of RFC in SAP. Four types of RFC in SAP here, right? So what is the synchronous communication here? What is the synchronous communication here? The synchronous communication is, suppose example, synchronous. This is the one of the system here, source system. This is the one of the system, one more system that is called the target system here. This is also SAP system. So this is also SAP system here. Maybe this is the target. This is the target here. This is the source here, SRC. Okay. This is the source system here. So here source will send the data to the target, right? Target here. While sending the data to target, there is a mechanisms. There is a here. So here the synchronous RFC means requires the both source system, the target should be available at the time of communication, at the time of data transfer. We both should be available here. This is the most common type and is required immediately after the execution of the RFC here. Right? Communication between the systems, which means, so here what will happen here when the sender data to the here, then it will send the acknowledgement back. Acknowledgement means delivered, something like that. It will send the acknowledgement back to the your source system here. Means here one order wise, the sequence wise, the data will be transferred to the target. The target will send the acknowledgement back to the source saying that I boss, I have received the transaction, something like that. It will send the acknowledgement here, right? So acknowledgement are required here to send the one more data here. It will send the first message to the my mobile to your mobile. So you will get the, I will get the acknowledgement from the your mobile saying that delivered, something like that. Previously we have this option in the not smartphones. We have the in something touchpad. We have the initial phones. We have the option when we send the message to your mobile. Yeah, I will get the acknowledgement saying like delivered, something like that. One beep sound will come, right?
Yes, yes, yes.
So right. So now, so same as like when you are sending the data from source to target here, once the data is received, it will send the acknowledgement back saying that, so hi source, I have received the transaction. Please send me the one more data. Then it will like that series wise, it will transfer the data here. In any case, the issue is if the target system is not available, source system resources wait until target system is available. This may lead to process the source system, the processes, the work process in the source system will go into the sleep status, RFC, CPIC mode at the target systems, and it will block the resources until target system is available. Then it will wait. Source will not send any data. It will wait for some time. Then once the acknowledgement is received, then it will send the acknowledgement again, starting and again like that. It will transfer the data here. So which means at the time of communication between source to target, both the source system and target system should be available where acknowledgements are required here. Where the acknowledgements are required here, right? So that is it will ensure that they are delivered to the target, that they are delivered to the target, and the data is consistent and reliable for the communication, right? So that is the communication between the systems and everything here. So the second one is the first one, that is called the synchronous here, right? Sync, first one is the sync means acknowledgement is required here. Asynchronous means the reverse order of the synchronous here. Reverse order means there is no acknowledgements are required here, no acknowledgements are required here. Asynchronous, the communication between the systems where acknowledgements are required, it is similar to the postcard delivery. So postcard delivery. Now postcard delivery means you will post the one card to your friend. Then that is the postcard delivery. There is no acknowledgement is not required. So we are not sure. Source is not sure whether that is received to the target, when that received to the target or not. We are not sure. Just you posted a card. So acknowledgements are not required here. So which means the same simple example postcard delivery here. It does not require both the systems to be available at the time of execution, and the results are not immediately required send back to the calling system, and source system it's not required to send the acknowledgement. Source will keep on sending the data to the target does not require send the any acknowledgement back to the source system here, whether it is received or not here. So in case of source system does not, so means source system it does not wait for the target as the it will deliver the data or waiting for it does not wait. So it's keep on sending the data, but it will does not bother about why my target received or not the data and everything here. So in this case, this is not the reliable communication. This is not the reliable communication, since data may be lost if the target system is not available sometimes. So this is maybe used for the parallel processing purpose. We will use the asynchronous mechanisms, and that purpose we will use the asynchronous. These two are the internal mechanisms. We don't have any transaction codes or anything, just theoretically. So these are the types are there here. Only these two types are there. Where the synchronous is acknowledgements are required here, then asynchronous there is no acknowledgement. Even with the target system is so there is no reliable communication. In case of target is lost, target system is shut down, even though it will send the data to the target. So you keep on sending the data. In case of target system is not available, it will not wait for the acknowledgement. It will keep on sending the postcard to your friend here, right? The next one is the very important, that is called the transactional RFC here. So transactional RFC, that is called the TRFC. The transaction code for the transactional RFC is the SM58 is the transaction code here. So transactional RFC means it's same kind of transactional RFC is same kind of asynchronous RFC method only, but only thing is when the sending the data to the target, for each and every transaction it will assign the one transaction ID. So when the sending the data to the target, it will assign the one transaction ID. In this way, even if the data is sent multiple times due to the some network issues, remote system is need not to be available at the time of communication here, which means so if the target system is down also, it will assign the transaction, it will keep on wait it here. Then as soon as your target is available, it will send the holded data to the target system here. So it will send the data to the target system here. Means there is a one unique transaction ID will assign to the each and every data. Then so in this way we don't have to so worry about the so data loss or anything. Why? Because as soon as the target is available, there is a transaction ID. By using this transaction ID, data will send to the target system. Even though the transaction ID already available, it will get stuck in the source system only, the duplicate data and everything here, right? So it's similar to the registered post here. This is the asynchronous
Sir,
is
the T code is SM58 or 59, sir.
58 for the transactional RFC. RFC connections creation SM59. The transactional RFC stuck, whether any RFCs are stuck, any transactional RFCs are stuck, that entries we can see it in the SM58. RFC connections creations and everything, we can do it in the SM59 is the transaction code. But this is a transactional RFC entries. Whether in your system, if it is going to the target, it's stuck or not, we can see it in the SM58 transaction code.
Okay, got it. Thank you.
Okay, so that is the thing here. So So here there is a scheduler. Even the target is unavailable, not available, the data will stuck here. So that scheduler will, as soon as the target is available, the data will send to the target system here. So normally the transaction code for this communication is like, so if you go to SM58 transaction code, normally I will show here some transactions are available here. Here I will show you the transactions here. So here, if we go to the SM58, SM58 is the transaction code here. Here we can see the status of the transactions and everything here. So if any daily, we need to go to this SM58 and see are there any stuck entries in the system. Means normally data exchange will happen via this transactional RFC only. If any user did any transaction, there is a transaction ID will be generated. So this transaction ID, so these transactions will cause these transactions are processing with the other systems, or it's failing in the system or not. It will give us the some clear picture here. It will give us the some clear picture here. So that is the reason. That is the reason. So we need to check whether any transactions are stuck in the system or not. It will provide us the results here. It will provide us the results here. That is what, so we can check it out in the systems here. That is what we can check in the systems here. Transactional RFCs here. So that is the main thing here. We can see here transactional RFC in SM58. You can see, so the target system which is going. Target system means how we are connecting to the target system via RFC destination. This is the RFC destination which we are sending to the target system here. Right? Via RFC destination we are sending to the target. So here this is the RFC destination. So here via this RFC destination which we created in the SM59, we will transfer the data to the target system here. Target system here. Right? So here you can, if you observe it here, let me fill it here. Yeah. If you see it here, if the target system is not available, the data will get failed here itself only. The data will get failed here itself only. There is a, see, there are a lot of transactions. See here, if you see here, so transactions are stuck here. So each ID, there is a transaction ID got assigned here. Transaction ID got assigned here. So right, each and every system, whatever they do the transactions here, they have some transactions are generated here. They have some transactions are generated here, right? They have some transactions are generated here. You can see the transaction IDs here. So whatever the people will do the transaction using the transaction codes, so each and everything will generate the one transaction. The transaction got stuck here. See, lot of transactions are got stuck here, right? Because of, so this is going to the target system. Even though the target system is not available here, the target system is not available. So that is the reason, as soon as the target system is available, the data will be sent to the target host. So now it is not sending to the target host. Why? Because these transactions are not happening in the systems here. That is the main thing here, right? So all are got stuck in the SAP systems here. So data communication is happening here. If you see the other systems here, other systems, we don't have any data. Sometimes we won't get any data here. Why? Because there is no communication. There is a functional work is required here to transfer the data here, right? Suppose if you see our ECD system, maybe one or two entries, maybe that may be the reason. So let's see here. Yeah, there is a one entry here, one entry format error here that got failed. So in case of, if you want to reprocess that entry here, reprocess the transaction code here, what we can do, we can execute the LUW. We can execute the LUW. So this will be processed to the target here. This will be processed to the target here. So here you can see, so I have just re-executing the transaction here. So which means this will process to the target here, exception raised. So this is not going. Why? Because here format error, the data, the format error here, the format error in this transaction. So one transaction ID got assigned here for this LUW here. So it is in the binary code format. So we cannot read it, but system can read that format, what is the data and everything. System can read it here. This is called the transactional RFC. The transactional RFC means, so it will send the data, source to target, it will send the data to the target via RFC destination. This RFC destinations we have to create in the SM58 transaction code. So it will send the data to the target here. So in case of the target is not available, something is happening, then you can see the data here. You can see the data will be stuck in the here itself. The data will stuck itself in the source itself. As soon as target is available, it will send the data to the target. That is the main thing of the issue here. IDOC workflow error. There are many things, so will get stuck here. The user, who is the user here? So if we want to reprocess, we can do the just execute the LUW. So we can reprocess the entries here. But that entry already there in the target, then it will not do the reprocess here. It will not reprocess the entries here. So that is what it will happen in the systems here, right? So coming to the here, this is the transactional RFC that we will call it as the TRFC,
Sir,
transactional RFC.
sir,
When
one doubt, sir. So if it's not possible for reprocess, what should we do? I
you
mean,
need
like
to inform to
stuck
the
in.
functional team, they will take care of the data format error and everything. Nothing we
Uh-huh.
do here.
Okay, okay.
So the next one is the transactional RFC. The next one is the queued RFC. So this is also queued RFC. This is also very important here, queued RFC. Here the queued RFC means the data will go to the target system. Both are like a sending the data to the target system only here. But the queued RFC is extension of the TRFC, transactional RFC. So here in the order wise queue means when we are onboarding to the bus or so, then there is a queue, we have to follow the queue, means order wise we need to get into the bus, right? We have to onboard the bus, right? Same as like here, order wise which is specified by the application, the transactions will process by order wise here. Order wise, the transactions first in first out, the transactions will go to the so target system here. Order wise, so the transactions will go to the here. So the order can be serialized, means order can be defined by using the queues here, by using the queues here. That's why queue order, queues queue-wise, the data will be transferred to the target system here. Data will be transferred to the target system here. So that is called the queued RFC here. Here there are the two types of queues are there here. Two types of queues are there here. One is the outbound queues. One is the outbound queues. Second one is the inbound queues here. Outbound queues and inbound queues are there here. So outbound, which are going outside of the system. Inbound means which are coming inside of the system here. Outbound and inbound, which are going out, which are coming inside of the system here. For this one also we have the transaction code here. So if you go to the SMQ2 transaction code, which are like a inbound SMQ2 inbound transaction. SMQ2 is like a inbound transaction code SMQ2. So here outbound like SMQ1 transaction code here, SMQ1 transaction code. Using this transaction code, we can monitor the queues here. How many queue entries are failed here? Inbound, which is coming inside of the system here. Your inside of the system means which is coming to your system only. Your system only, this queues got stopped here. Maybe the queue got locked, I think here. So we can unlock the queue, and we can reprocess the transaction here. Go to here, then there is a reset the status here, right? So we can execute it here. We can execute it here. This is the queues here, which is coming inside of the system. From other system to your system, these are the queues here. XB, RQ star, XB, RQ, XB, RA, XB. So these are the queues here. Normally these queues will be defined by our functional guys, but our duty is as a day-to-day, we need to monitor the queues here, inbound queues and outbound queues and transactional RFCs here. So if you see here, if any queues got stuck here, data got stuck here, data got stuck here. So which means we need to try to reprocess it. Is still failing, we can inform them. Then SMQ1 is like a outbound queues here, outbound, which are going outside of the systems. So anything, any data which is going outside of system via RFC destination only, it will go. Via RFC destination only, the queues will go to the target system. The data will go to the target system. These are the queues. So this data is going to the BW, GRC, CRM, CF, our APO systems and APO, BW. There are the multiple TM. There are the multiple data is going to the multiple target systems here, right? Multiple target system, the data is going here, which means the data is if the via RFC destination, the data is going to the target system here. The data is going to the target system here, right? So this is going to the GRC system, GRC underscore RFC destination. So this is going to the BW system. This is going to the ECC system and APO system. So from your system to it is going to the multiple systems via RFC destination. But it's the entries are going via order wise. Order means the queues wise. So the data is going to the target system here. The order wise, the data is going to the target system here, right? The data is going to the target system via queues wise. The data is going here, right? So this is a queues, inbound, outbound queues here, right? So SMQ2 inbound queues, SMQ2, SMQ1 here, Q2 inbound, which is coming inside of the system. Suppose example, if you see, this is going to this system, it is going to the outside. So then it is the outbound queue. Then immediately it will come to the inbound queue here. Then which is going to the out. This is the outbound queue here. Again, it is coming to inside of the system here. This is the inbound queue. Each system there is a outbound queue and inbound queue here. This is called the inbound, right? Which is coming inbound. Then which is going out. Out means outside of the system. Outside of the system, how it will connect via RFC destinations here, right? This is called the inbound here, inbound. So then this is called the outbound here, out, which is going outside of the system here, outbound system here, right? So the data will go to the one system to other system here. So here there is some transaction is happened here. Then inside of the system too, it will go to the outside, from outside to system inside to, then it will come to the inside of the system here, right? Here, some records will be inserted here. Then again, same data will go to the target via outbound, then via queues wise. Then it will go to the, again, it will go back to the previous status here. Then it will come to the, again, inbound here. Why? Because data flow will happen from one system to other system to one system here. Then how the data will go for means inside, inflow, unbound to outbound, outbound to inbound, the data flow will happen here. System which is going to connect to the outside of the system means via RFC destination only. That's why we see in the outbound, we can see the RFC destinations here, SM. So Q1, we can see the outbound out, which is going out. So via RFC destination only, we can see the entries here. We can see the all the entries here. That is what we can see it here, right? So then, so like this, we can transfer the data. Sir, where can we define the queues here? Where can we define the queues here? So there is a so transaction codes, which means we can also create the queues. Normally, we will get the request. Normally, checking the entries, is there any outbound entries are stuck? Is there any inbound entries are stuck? Is there any transactional RFCs are stuck? We can check in these three transaction codes. But where can we check where can we create the queues here? Queues creation, right? The creation of the queues here. Where can we create the queues here? So where the functional team will define the queues here. Where to check the queues here. So there is a SMQR, SMQS are the transaction code. Here we can create the queues here. If we go to the SMQR, so here there is a inbound scheduler, which is coming inside of the system. Then here we can define the queues here, how the data will come to your system. So let's say XB, sometime like XB star. This will be defined by the your team only here. Then we can create the multiple keys, multiple XB, XA star queues, XB star queues, XC star queues. Then so there is a queues, we can define it. Via this queues, data will come to inside of the your system here. Otherwise, it will come to your system here, right? So otherwise, if you want to define the outbound queues here, Then SMQS is the connection. Then we can schedule it the outbound connection here. Out, which is going out. Out, how will go? Via RFC destination. Then we need to check which RFC destination is currently available in the system, right? So there is a ECD system, right? There is a ECD to then ECP, ECD. So there is a ECD system is available. Then we want to send the data to the ECD system here. Then I just mentioned the ECD here. Then you want to send the BW system. Then BW connection you need to check. We can send it to the BW system. Means before that only we need to create the all RFC destinations. We have to create it. Then we have to maintain the queues here. We need to maintain the queues here. Queues creation. We have to do that one here. Then we can transfer the data. Suppose sometimes we may have to send the data to the so P okay, P. Then P connection also you created here. Via this connection, the data will go to the target system here. Via this connection, the data will go to the target system here. So like that, we can define the queues here. Like that, we can define the queues here, the queue scheduler here. So this is the queues creation. So here, what will happen if you define the entries here? Then functional team will transfer the via queues. Functional team will transfer the data to the respective target systems here. So the data exchange, IDOCs, IDOCs, the many things will go via queues only here. The target system via RFC destination here. So this will happen in the systems here, right? So source will come see here. The suppose like one of the user got done the transaction here, right? So the transaction requires some data, some IDOCs will transfer from IDOCs will start here. Then IDOCs means intermediate document that contains the more data here. Then they will send the data to the target system via RFC destination. They will send the data to the target system here. Then target via inbound target will receive to the system here. Here some records will be inserted, some format will be changed, some adjustments will happen inside of the system. Then again it will generate the record. Then it will go to the target ANA system here, right? So like that, the data transfer will happen from the one system to another system, one system to another system. The data transfer will happen here. This we called as the so inbound queues and outbound queues here. So where can we create the queues means in the creation of the queues SMQR, SMQS we can create it. But where can we monitor? Why? Because in the real time systems are in the real time means there is a lot of transactions will happen and the data exchange happens between the systems here. So where can we check means in SMQ1, SMQ2 we can check the queues entries and everything we can monitor it here. So that is the main purpose of the checking the queues and everything here, right? So that is the one thing here. So day to day, we need to check this three transaction code check. If any entries are stuck here due to target system is not available, then we can bring up that BW system or EC system, we can bring it out. But it got stuck due to the some functional error, data error, something like that, then you need to inform to the your functional team. They will take care of the respective actions here. Okay.
Sir, here we have seen many entries, right? 3,676 like that. So, like, can we delete it?
Yeah, we can also delete the data, but you need to get the confirmation from the functional team here. If you are deleting the data means you are deleting the transaction. So functional team said like this is a duplicate data, it's not required. You can delete it means non-production systems, we can delete it. Production systems, carefully we need to check that one. Why? Because the data is like one of the transaction. If you delete it, the transaction will be deleted. There is no record. Again, tomorrow the record user or someone, if they are checking something, the data is not available, again it will create the big problem, right? So that is the main problem here. So production, if you are deleting something, you need to check with the functional team that record is exist or not in the target. They will confirm based upon the confirmation, based upon the approval procedure only. You need to delete all these entries in the productions.
So where we can check which user is executing this one?
So here you will get the options, right? So if you just select, double click it out here, what is the queue, and so then who is the user? It is initiated here. Caller means user. Then which client? What is the queue name? What is the destination? Which system it is going? And all the information it is available here.
If it is a duplicate, if it is failing due to duplicate data
It is the
card, then
failing
we
like
can
it
delete.
say like it is invalid or duplicate something like that. We will get the status here. So that time, so we can delete that entry. So if the functional team asked us to delete the entry, we can delete it. Whatever, if we want to do something here, deletion or reprocessing or something, You have to wait for the confirmation from the functional team only. Why? Because functional team is responsible for the data activities. We are only technical team. The data confirmation and everything functional team only.
So in the day-to-day monitor, we no need to reprocess it, right? Until we
No,
get
no, no.
confirmation.
Until we will get the we have to just check the whether entries are stuck or not. If any entries are stuck, then send a straight away can send a mail to them.
So we no need to reprocess, right?
Right. Until unless if they confirm.
Okay, how to reprocess here in SMQ?
There is
If they
a
confirm in SM-Q1 and Q2, how to reprocess it?
reprocess means there is a option execute LUW, right? So there
That
you
is in SM58, right?
both are
Same for
same for
both.
here as well.
So that will execute all the entries, right? Which is
One entry, if you
displayed.
want to execute one entry, you can execute. If you want to execute the multiple entries, you can execute the multiple entries here. There is a, so if you go to the inside of the queue, there is a lot of entries got stuck here. Select that entry, go to the execute LUW, that is fine. So then if you execute LUW, so if the exception is raised means we cannot reprocess those things here. But because only this user can reprocess the entries here. So then otherwise the HR team, so other functional team, they will take care of. They will run the job and they will take care of the triggering this and everything here. We want to bulk process here. So there is an option execute LUWs or reset the status here. The status will be reset, ready. So then it will process it here. All the queues will be processed here. Okay. So
Hello.
this is the yes.
Sir, in transactional RFC, like only difference is for each entry that one transaction ID will be assigned, right, sir?
Right.
That's it. That will be moved to the next system based on the
Yeah, using this
transaction ID.
transaction only, it will be moved to the next system. So that in this way, oh, the duplicate data will not send to the target system. Only the
They,
correct data, valid data, it will send it out. If the duplicate data already sent, so then it's already there in the duplicate, same transaction already there in the target. It will say like the data already exists in the transaction. This entry will get stuck in the source itself.
oh, sir, is it like both systems should be available at the time of uh,
Transactional RFC it's not required. Only synchronous RFC, both the systems should be available. The transactional RFCs or anything, target system is not available also. Source will keep on sending the data. As soon as source target system is available, then source will transfer the remaining records to the target.
okay, sir.
Sorry, it must configure, right? SMQ1 and SMQ2, right?
Yeah.
In our system is not.
So if you execute the LUW1, if you execute the LUWs here, all will gone. So all will be executed. So then which date to which date? So then just to you can select which one you want to execute it here. So then execute it here, valid date. All will be executed here. The date we have to maintain here. Maybe so last 2022.